Hey guys, I'm Ashley Shaner and I'm here to teach you, yes you, about lesson 10.5, arc area and arc length in polar coordinates. It's not that hard, I promise you. Super easy, you just got to look at it the right way. So, first we'll start off with the textbook definition, then we'll go into some examples and my method of how this thing should work. So, if f is continuous and non-negative on the interval alpha to beta, 0 is less than beta minus alpha is less than or equal to 2 pi, then the area of the region bounded by the graph of r equals f of theta between the radial lines theta equals alpha and theta equals beta is given by a, which stands for area, equals half integral alpha to beta f of theta squared d theta, or area equals half of integral alpha to beta r squared d theta. If you just know this and how to identify it, you're pretty much good. But just in case you somehow forget, if you know the area for a sector, you've got this. It's essentially the same thing. So remember when we were working in rectangular systems, you know, regular x's and y's, nothing with this polar stuff. You were working in rectangles. You were finding the area of each rectangle, adding them all together, and getting the area under the curve. You're doing the same thing here, but because it's polar, you're working with circle sectors. That's why knowing the formula for a circle sector helps a lot if you're trying to figure out what this equation is. Look, I'll even help you break it down a little bit. We'll write it in blue. So, area equals half. And we integrate from alpha to beta. Theta is the d theta, so this and this are the equivalents. And r squared. See? If you know this, you can get this right here. Isn't that really cool? Alright guys, so now we're finally going to get to an example after that long and droll definition. So, our first example is find the common interior of r equals 3 minus 2 sine theta and r equals negative 3 plus 2 sine theta. Well, the first thing you want to do is identify what type of polar graph that is. Now, you're probably moaning and groaning. Trust me, it's not that hard. As long as you know your limacons and your cardioids and your rose petals, you should be fine. But if not, go find another video and figure it out, because I'm not covering that. So, first, we're going to identify. So, we'll use this one. And we only have to really identify one because these have the same number, so it's the same thing. It's just different signs. So, we're just going to ignore the signs. So, A equals 3, B equals 2. A over B is 3 over 2, which is 1.5, which is greater than 1, but less than 2. So do you know what that means? It's a dimple limaçon. So we'll write that down so we can identify it. Limaçon. I have a pet fish named Limaçon in my math class. Oh, he's so cute. He's adorable. I love him. So, now that we know it's a dimple limaçon, we even know what type of graph it is. So I'm going to change colors. I'm going to go from purple to blue. We're going to draw this thing. So obviously I'm going to do it very roughly. You should know how to graph these. It's very important. You'll need them. But when you're on the AP exam, obviously, be very precise. So we'll do this one. So sine of 0 is 0 times 2 is 0, 3 minus 0 is 3. So over here, this is 3. First point. So now we do pi over 2. Sine pi over 2 is 1 times 2 is 2. 3 minus 2 is 1, so we're over here 1. We'll connect it. Next one is pi, so sine pi is 0 times 2 is 0. 3 minus 0 is 3, so 3. And then knowing we could just graph the rest, but because we're always short on time here, we'll just do this. That's what it looks like. But don't forget this one. It's just a reflection. So all you really need to do here is this. But always remember, on the AP exam, you need to be precise. So, okay. Now you're probably looking at me, Ashley, that just looks like a bunch of lines and circles. It's not circles, they're only mistons. Don't offend my fish. So, first we need to color in what we're actually looking for. So I'm going to switch to orange. Okay? So we're looking for the common interior. That's right here. This part. Let's pretend like I can color in correctly. Right there. Now, if you realize it's a reflection, that means all four of these are exactly the same area. There is no point in going forward and looking for every single little one. So we're just going to multiply this whole equation by 4. And if you just did it from 0 to 2 pi, you're going to end up with an area that isn't as accurate. So let's make it simple, make it easy. We'll get the answer quickly and probably more precisely, unless we can't math right, which most of us can't do to begin with. So I'm changing to green now, and we'll start with our equation. So from what I said before, we know our equation, it starts with this A, means area. Now, normally it would be half, but because we're going to find only one section, we're going to multiply this by 4. Just don't forget the 4, or else your math will be off, and it'll be horrible. So then we put the integral. So now that we're working with 4, we're only looking from pi over 2, from 0 to pi over 2. You have to make sure everything is precise and everything matches. So since you're only looking for this part, you only need the interval or the limits to go from 0 to pi over 2, and then you need to multiply 4 to get the rest of everything else that is colored, all of the orange. So now we have to just continue. And so at this point, we are looking here. Okay? So to get this, we used this equation. We only need this line. See, if we had done it the other way and just done the whole thing, we would have had to get this one involved. Now it looks like a lot of work that wasn't worth it. So we'll just do this one. 3 minus 2 sine theta squared d theta. Don't forget the square. Don't forget the d theta, or you're just going to have a mess and you're going to be crying and your whole AP exam will be ruined. Ugh. I know. It's a horrible day. Anyways. So now, before we move on to a new sheet of paper where I'll actually do some more math and like the fun part, the integration, we'll have to square this. And so let's simplify it more. A equals, well, 4 times half, let's just simplify that, that's 2. And then we have the integral. We can't really change the limits at this point in time. We will square. So 3 squared is 9. 3 times negative 2 sine theta is negative 6 sine theta times 2 is negative 12 sine theta. Negative 2 sine theta squared is plus 4 sine squared theta d theta. It's not that hard. Now you can obviously see that there's something wrong here. We'll address that in the next part as soon as I switch this paper. Okay, so now we have to deal with this little part, which we can't really integrate. But using your trigonometric identities, which I hope you know they're kind of important, you really need to review them. You really need to know them. This is simple. Sine squared theta is equivalent to 1 minus cosine 2 theta over 2, yeah. So we just replace it. A equals 2 pi over 2, 0, 9 minus 12 sine theta. Now there's 4 times this, so 4 over 2, that's only 2, so we'll just get rid of the 2 already. 1 minus cosine 2 theta, d theta. Yep, so now we combine everything, all like terms. So A equals 2, 0, pi over 2, 9 plus 2 is 11. I definitely knew that off the top of my head. 2 sine theta minus 2 cosine 2 theta c theta. Math is exhausting, man. I don't know how I make it through the day at school. So, now we integrate. A equals 2 11 theta 12 cosine plus 12 cosine theta, and then we can find this part, so it's minus sine 2 theta. Alright, so now we have, after we've integrated 2 11 theta plus 12 cosine theta minus sine 2 theta. Don't forget your limits over here, you could lose points. Alright. So at this point now, all we gotta do is plug everything in. So A equals, we'll do the 2 later. 11 pi times pi over 2 is 11 pi over 2. Cosine pi over 2 is 0 times 12 is still 0. 2 times pi over 2 is pi. Sine pi is 0, so it's minus 0. Makes my life a little easier, make sure it's even easier. So 0. 11 times 0 is 0. Cosine 0 is 1 times 12, so it's plus 12. 2 times 0 is 0. Sine of 0 is 0, so it's minus 0. So A equals 2. All these zeros can go away. 11 pi over 2 minus 12. And then we can just distribute that 2, so it's 11 pi minus 24 units squared. It's really that simple. It's not very hard. I know it seems really hard, but once you get through it, you realize it's super simple. Like, why couldn't I do that before? It's really easy. Alright, so now let's move on to arc lengths real quick before we wrap up this video. I didn't write down the definition, but I'm going to read it off to you. Let f be a function whose derivative is continuous on an interval from alpha is less than or equal to theta is less than or equal to beta. The length of the graph of r equals f of theta from alpha to beta is this equation. This equation is going to end up being your lifesaver, so I would remember it. And this equation is s equals interval alpha to beta radical r squared plus dr d theta squared d theta. So we're going to do only one example here. We're going to do r equals 1 plus cosine theta. This is our equation. Let me just circle that. Now, you may be looking at this interval and be like, what? That's a really weird interval. But if we don't do it from this interval, we're going to end up with an area of 0. And, you know, that doesn't sound fun. You can't really have an area of 0. I mean, who would want no area? It doesn't happen. And that's because half of the graph cancels out the other half of the graph, because area is negative in one part and one isn't, and then negative plus positive equals 0. And, it's a whole mess. It's like a circus down there. So now, first what I suggest doing is identifying what type of limit this is, or what type of graph, and then we're gonna draw it. So a equals 1, b equals 1, this is 1 over 1 equals 1, which is a cardioid. So just a quick sketch of what this looks like. Now obviously on the AP exam, once again, you're going to have to do this precisely. So it looks something like that. So the area you're actually looking for is inside here, in this red, right there. Okay, so now we can actually do the math. So let's look at our equation. S equals interval. Our alpha is negative pi. It's pi radical r squared. What is our r? Well, they gave it to us, so we just gotta square that. So 1 plus cosine theta squared plus the derivative. Ugh, we don't have the derivative. What are we going to do? Well, derive, duh. So dr d theta equals derivative of 1 is 0. Cosine theta is derivative is 9 sine theta. So we'll just put that little nice negative sine theta squared, and don't forget that d theta. It's very important. You'll lose a whole bunch of points. So now we can just integrate, and I'm actually going to change colors. I'm feeling blue right now. So, whew, that's getting a workout over here. So let's expand. S equals negative pi to pi radical. 1 times 1 is 1. Cosine theta times 1 is cosine theta plus times 2 is 2 cosine theta. Cosine theta squared is just cosine squared theta plus negative sine theta squared is sine theta squared, and then d theta somewhere over here. Now, before we can actually integrate, we actually have to somehow condense this. Now remember, trigonometric equations are your best friend. So do you remember that unit circle thing where sine squared theta plus cosine squared theta equals 1? Well, watch this magic right there. That equals 1. So S equals that integral negative pi to pi. This equals 1, so it's 1 plus 1, it's 2. And there's going to be 2, so we'll just take out the 2 right now. So 2, 1 plus cosine, oh, I forgot theta, d theta. And then we can use one more trigonometric equation. So this is, do you remember the one that we were using before? Cosine theta over 2 equals cosine squared theta. Well, we don't have this division over here, so we just have to divide the theta by 2 over here. You see that? I'll write it better in the equation. So all we gotta do is now that, and so we just replace this, so it's something we can actually work with. And there's going to be 2 of those in the equation. So can I write it down here, or do I move it down a little? Yeah. So S equals negative pi to pi. Now there's 2 of those, so it's actually 4 when you replace it. So 4. And then we'll replace it with cosine squared theta over 2d theta. And then in the next paper, I will actually integrate, and you'll get your answer very easily. Alright guys, so I went ahead and wrote it out just so we can move faster while I spoke, and you can get a look at what I was doing. So here was what we left off with. So now we have a problem here. Like, how are we going to do that? So basically, if you square root it, you can do it, because 4 perfect root cosine squared theta over 2 is another perfect root, so you can just get rid of the radical, and it's 2 cosine theta over 2 d theta. Easy, simple, you got it. Was my head blocking it? Probably. So now just take out that 2, because 2's are pains in the butts. Now you have to use chain rule. So u equals theta over 2, and the derivative of that is half of d theta. So plug it all in. We need to account for that half, so we're just going to put 2 in. So it's 2 cosine u d theta, du. Okay. Now we just take out that 2, it becomes 4. Now you have cosine u du, which it's much easier, much simpler. And you can integrate that easily. And it's obviously positive sine u times 4. Don't forget that the interval is negative pi to pi. Okay, so now with this, we replace the u, which is over here, this u, for positive sine theta over 2. Now we evaluate our limits. So we move it down a little. So now we evaluate it. 4 bracket parentheses positive sine pi over 2 close parentheses minus parentheses positive sine negative pi over 2 close parentheses close bracket. So sine pi over 2 is 1. So it's positive 1 minus sine negative pi over 2 is a negative 1. So it'll be negative 1. But because these two are negatives, it's positive. So it's S equals 4. 1 plus 1 is 2. Can you see that? Yep. Equals 8 units. And that's it. That's how you found the Arclength. It's really simple, really easy. I bet you can do it. Thank you for watching this wonderful video. I hope you have a great time with that AP exam. Hope you pass. Get that 5, get that 3, whatever you want, just not a 2 or a 1. Thank you for watching once again. I hope I helped clarify things. I clarified them for myself before I actually did this. So, yeah, thanks. Good luck. Have fun.